So it says to find the volume V obtained by revolving the region between f of x equals x squared plus 2, so that's my parabola right here, and g of x equals 4 minus x squared, so that's this guy here in green. And we're revolving it about the x-axis. So recall it's this area right here between these two graphs that's being revolved around the x-axis. Since the area is further away from the x-axis, this will result in a washer. There will be a hole inside. And so we need to find these 2 points of intersection, which happens to be -1 to 1. And if I remember, when I look for the volume of a washer, remember our formula is pi from a to b of big R squared minus little r squared dx. Big R is the graph that's further away from the axis of rotation. So what's further away from the x-axis? This green graph, which is my g of x. So this guy comes first, my big R, minus the red is closer, so that's inner. That's my inner R, since it's closer to the x-axis. Don't forget, each function must be squared, so use parentheses, dx. Since I'm rotating about the x-axis, then with these points of intersection, I'm using just the x values. Oh, let's not forget pi. My functions are in terms of x, and this is dx. If I was rotating about the y-axis, I would use the y values for my interval. My functions would be in terms of y, and this would state dy. So if I plug this into my calculator, I get my volume is 16 pi. And it's volume, so we can say units cubed. Now, today's lesson was to revolve a solid around any horizontal axis. So not just necessarily the x-axis, but any horizontal line. So if I look at my first example, find the volume obtained by revolving the region between f of x, x squared plus 2, g of x, 4 minus x squared. So we have the same functions, but now instead of revolving around the x-axis, we're revolving around the horizontal line y equals -3. Since they're the same 2 functions, I can use the same diagram. I'll just draw on the line y equals -3. And so this area, I am now rotating across this line down here. So I can see that this area is further away from the x-axis. So my volume is going to be a bigger volume. It's still going to be a washer since there's space in between the area and the line. But I need to account for this greater distance. Since my graph is above the line, I can take, well, let's look at the first one. This guy is still further away in green, so g of x is still further away, and he's above the line, so I will take my 4 minus x squared minus the line below, -3. And I end up with this negative and negative is positive, so 4 plus 3, I get 7 minus x squared is now my new g of x. And f of x here, well, this is my little r. It's inner because, again, this graph is closer to this line, but it's still above the line, so I will take my x squared plus 2 minus the -3. And I end up with x squared plus 5. So these will be the 2 functions I use to account for my big R and my little r. So again, it's still a washer, so I'm finding this volume. I still have those same intersecting points. But now, instead of 4 minus x squared, I accounted for that greater distance, and I have 7 minus x squared being squared, minus my little r, x squared plus 5 squared dx. And now you can go ahead and plug that into your calculator, and you should get 32 pi. units cubed. It was a greater distance, so we did expect the volume to be bigger. Let's look at another example. Do two more examples. Here we're finding the volume obtained by rotating the graphs of 9 minus x squared and y equals 12. They give us an interval, and it's about the line y equals 12. Well, what do you notice? We're rotating a line over itself. So, what do you think that means? Well, if I look at the picture, I'll draw a graph. I have 9 minus x squared, so up here is 9. It's negative x squared, so I'm going down. That's this guy. Y equals 12. 12 is above my 9, so that's some line up here. And if I am revolving about this line, well, if this line is revolving about itself, do I get any volume at all? No, it's just revolving. It's not going anywhere. But this guy is revolving around this line. So there'll be some reflection over here. And so all this space and all this space, do I still have a washer? Nope, there's no space in between. I will have a disk. And so, again, I have to account for this distance, because this is not the same from the x-axis. This f of x would be from the x-axis, but this is all the way up here. So I need to take away this distance. This guy's up here, the x-axis is down here. So now, instead of my function minus that line, since the line is above, I have to do the line minus my function. Don't forget to use parentheses since I'm using subtraction, so I have to distribute. So I get 12 minus 9 is 3, negative, and the negative is plus x squared. So here's my new f of x. Technically, if I wanted to use the same method as here, I can say, well, here's my line minus this function, and this just gives me 0, which shows me there's no hole. So there's no, it's a disk, not a washer. So I have pi, I have the interval they give me, oops, my interval is from 0 to 3, my function is now 3 plus x squared, my r squared, dx. And when I plug this into the calculator, I get 648 over 5 pi units cubed. One more example. Find the volume obtained by rotating the graphs of f of x equals sine of x and g of x equals x squared about the line y equals 1. So, important to draw the sketches. I know sine of x, well, let's do him in green. Sine of x looks something like that. And I know x squared is something like this. Then the line y equals 1. Oops. Somewhere over here, no, it's the top of the sine. So here's my area between those two curves. And this area, I'm revolving about that line y equals 1. So, since the line of rotation is above, it's above my graphs, again, I'll take that line of rotation minus my function, line of rotation minus my function to get my two new functions. And this one is the red. This one's my guy in green, just to keep it neat. And so now, which is my big R and which is my little r? Well, let's look. Which is inner? which function is closest to the line of rotation? Well, see this green? The green is closer to the line y equals 1 than the red is. The green is my sine. He's closer. This is my little r. The red is further away from my line of rotation. Further away is my outer. So this is my big R. And so now we can set it up. Pi, the integral, we got to find these 2 points of intersection. So you can use your calculator to find those 2 points. Let's set these guys equal to each other. And we get, I'm going to go around this 3 places for now. And so I have my big R minus my little r dx. This is a decimal, so I'll plug this whole thing into the calculator, and we will not leave it in terms of pi. We'll get a decimal representation, so this guy is approximately equal to 5732 cubed. Make sure if you are absent to practice these next few problems.